Hello, hi everyone. Indeed, today we're going to talk about this new upcoming API to React. Contrary to many of you may believe, React is not perfect, at least not yet. And what's important to know that React is an idea. And the fact that the main implementation is in JavaScript is only because the JavaScript has the biggest distribution and is also the most popular language. But it also has certain barriers that we need to overcome when thinking about how to make React development the easiest. And today we're going to talk about what I believe is a very important step in React development and in evolution of the React infrastructure. So I used to work at Facebook pretty much around the time when React was first conceived. And it's a great thing about this library that it was actually developed by Facebook, a company which probably has the biggest front-end applications in the world, talking about Facebook.com, obviously, and also the Facebook mobile application, because actually Facebook Android application and iOS applications are the two biggest applications in their respective stores. So it's important to have a very good process of developing those views. And when I came back to Poland, I started doing a lot of React freelancing, and I got really much into this working for this organization, React Rangers, that helps developers land very cool remote projects that are only in React, so you get this comfort in gaining expertise in certain framework. So React was, it's actually 5 years since it was made publicly available. And it's really not meant for the browsers only. This is just a general idea that you can have some very good process of designing a dynamic front-end application that then can be rendered onto any platform that implements this. So currently we can have React web applications that are booming right now, and also you can have native applications that are also written in React, and the only difference between them is what sort of basic building blocks they're using. So in browsers you obviously will have the tags, and in native application you will have the native components that the same stuff the Android guys and iOS people are using. So just by learning this one thing, you have immediately access to all of those different platforms, and the new platforms are coming like virtual reality platforms, for instance. So talking about this, this very bright React idea, that can be really described by this simple math function, right? We have some data that defines the state of our application, and we need to tell React how we want to translate that onto the UI. So the way this happens is we need to write basically a lot of functions. And the bigger functions can be composed of smaller functions to sort of do this. And the UI result is just a declaration of how we want this UI to look like. And React will take that and create this onto the platform using those building blocks. So if you're working for web, you will use the HTML tags, and you will have a code very similar to HTML inside your JavaScript. But this is only the declaration of what you want this to become. And similarly, for mobile application, you will have the mobile components building blocks from React Native library. And this is awesome because you only need to write this function, and whenever the data changes, React will run this function again and do any updates onto the UI that are necessary. And this is very different than how it used to be. For instance, like people using jQuery, especially those who are in front-end development for a long time, know about this, that back in the day, we really had to think about what needs to be changed on the screen just because of what happened now. And it's not like that anymore. We just need to, we just can focus on the data, have this one transition of the data to the UI, and really those tools do everything else for us. But I mean, the functions itself aren't enough for any application, right? It's not only like translating the data onto the UI. There are the things that need to happen just after certain actions took place. So one of those is the component state, right? The function, the result of the function will change over time depending on what is being done in the application. So the function itself need to have some way of saying, now I'm going to behave differently because now I'm having this internal storage or internal state that can change, and it can also affect how the UI is going to look like. So that's a thing that usually doesn't come with functions, right? Another thing is data fetching. Virtually, like all web applications need to communicate with some other server to pull some data or like to push some data to the server, and that's also impure, right? I mean, it's outside of what we would call a function from data to UI. Also, animations usually start at certain points, so we need to have the notion of time, right? Which we don't in functions themselves. So there are all those different things that are really outside of what we would like to be this pure, simplistic way of writing only functions, and we need to accommodate for them somehow. So the initial idea with React was, let's create a class, and this class will encapsulate the life of component, and we'll have some ways of doing all those different things. But really, initially there was only those simple methods that people could use, like the constructor, the main render method, which is actually the function that we wanted in the first place. So there's also the set state, which we can set the internal state, and those three different methods, like being run by React on did mount, did update, and will unmount, all of those different phases. And they sort of like forcing us to put our logic in either did mount or did update or will unmount. And it's very many problems arise from that, because there is only like, so you basically all of the code that you want to write, you need to divide them into those three buckets. And it just gets very messy very quickly. And the only way to avoid that is actually to write very many components, which will be wrapped in one another to get some sort of separation, right? And like having very big component structure is also bad for just being able to understand your application. And the classes in general, it's so much harder to explain classes to people than functions, then it really makes the development itself much harder. So even though like React started with classes, there is this push to get rid of the classes and use functions again for something that by idea was a function. And funny enough, this is something that we've also approached in React renders. So we created this library called Stateful, which basically consists of this additional stateful component to which you can pass initial. Oh, wow. Yeah. All right. To which you can pass this initial state, which has a certain value, and by using this approach of having a function as children, then you write a function which gets this current state as an argument, and you basically output whatever UI you want from that. And additionally, you can just change the state by just assigning a new value to a property, and pretty much the component does the rest. This is pretty much to showcase that we can have an applications with state while avoiding classes. So talking about those problems with classes a little bit more, let's take a look at this example. So let's say there was a chat API that we wanted to get information whether certain person was available or not. So with the APIs like that, you usually have to subscribe to this information. So that would be obviously done in component did mount, because we would know from props what kind of friend we want to track. And if the tracking component goes out of the word, I guess, then we would have to unsubscribe from this. So even in this simple example, you can see that the code of the same feature now must be written in two different methods. And in any real application, then those methods would have more stuff, basically, right? So then you would have like on line number 100, you would have some piece of code of the feature, and on line number 300, you have the rest, which is the worst thing for maintaining code and catching bugs. And this is not only that. For what happens if the friends changes in props, right? then our subscription would be obsolete basically, because we would have to resubscribe to new data. So in case like this, in component did update, we would unsubscribe from the old friend data and subscribe to the new friend data, right? And many people actually forget about that and end up with components that only work for initial props pretty much. And this is a very popular error, which is pretty much due to certain limitations of the API we have today. And we will come back to this example and see how this is implemented better using hooks. And another thing is it's difficult to reuse logic. So let's imagine that we had this tracking subscriptions that we wanted to use in different parts of applications. So we would have like those icons, like avatars of friends, and the green icon would suggest that those people are available now, and the gray icon would say they're not. And also we would want to have a list of friends with a similar thing, right? And we would not want to repeat the subscription code, obviously, right? So what are we going to do in this case? And people have come up with certain ways to do it. Like the one thing is render, it's called the render props method, where you have some component which actually gets information in props on what it will render, and just by its own mechanics, it would be able to provide more information onto this whatever UI you want to render. So that's one thing how people do it. And the other one is just higher order components, which confuses a lot of people actually about what it is. But actually all those things are only to be able to reuse some part of components that are not the render function, which is not good, just because it really adds up to this hierarchy of components, which is becoming very difficult to follow. So here are the hooks. Interestingly enough, everyone can use them today with the alpha version, and the API has been discussed actually for a long time. So it's not likely to change much. It's more just subject to comments, I guess, and getting people to write more tutorials about hooks, so people are not freaked out when it goes mainstream. So what are hooks? So we started with the function, and I said that there are things outside the functions that need to be accommodated for, which classes were made for. Right now, our goal is to get rid of the classes. So how do we do it with the functions only? Hooks are actually additional functions that our main function can call to hook into certain React capabilities, such as state, such as lifecycle, and the context. The context itself actually doesn't require state per se, because you can have the context consumer just be like another wrapper. But again, like we want to get rid of the wrapper hell as well here. All right, so what React people say themselves is that the hooks are meant to be this better API that solves everything that the classes were meant for. But at the same time, we're not trying to like replace them, and the classes will be supported longer. But like developers are encouraged to look into hooks for any new project, because this hooks API is set to be easier to learn and also easier to maintain. So that's why it's important to keep that in mind. So we'll discuss three main hooks. There are more than three. I will discuss them briefly, and then we will talk about some general rules behind using hooks and how to write your custom hooks as well. So to start off, we'll talk about the most important one, the state hook, because like the main reason people would use use classes instead of function components, which used to be called the stateless components, but that's not the case anymore. So we just stick with the function components name, is the state hook, and this is how it works. So the simple example is just having a counter with a button. Like every time you click the button, the counter increases. So the way to do it, like we start off with the function component called example, we will import one new thing from the React library called useState. And this is a function. So we can call this function from our function component, and it returns an array with two values. By using the ECMA script 2015 array distraction syntax, we can name the two values of this function whatever we like. And in the first one is the value of the state, and the second one is the setter of the state. And this by itself is meaningful just because we named it in certain way. So in this case, our first use of useState will be for the count. So we call the value the count and the setter set count. And this argument here in brackets is the initial value of this state. And the state in this case can be whatever. It doesn't have to be an object. And also the set count or the state in general would just takes in a new value and replaces the old one. We don't have this mechanism anymore that like will merge the old state with the new state and like come up with the merged one. Here we can have as many use states, as many different pieces of states we have. So this doesn't need to be objects, and it's important to know that this is just going to replace the value. So in beginning of our component, we sort of like declare whatever state we want to have, call the useState function as many times as we need to, and call those different values and setters accordingly to what we want to store in there. And then we can just use it as a result of our return operation, render operation. So we render the count, and also we use the set count function to increase the count when we need to. And we can use the useState as many times as we want. How React keeps track of this is just looking at the order. So it sees that, okay, they called useState 3 times again. So the second time they called useState is for the same thing that they called it the second time in the previous render. So when we use the hooks, it's important to keep the order intact. And the rest just happens automatically. And you can also see that useState doesn't get any information about what component it works for. It doesn't, for instance, get the this argument. But it's really not necessary because in a single-threaded JavaScript environment, React works one component at a time anyway. So there is some global state information just pointing at the component being rendered right now. So if you use useState, it can be only used. React already knows what component is being rendered, so there is no need to pass any additional information to useState. Also, this initial information here is going to be used only for the first render. So if the initial state was expensive to compute, you can use the additional syntax for passing a function into the useState. And this function will be called only initially. So if you have some expensive computation to perform to get the default value, to get the initial value, you can use the function as an argument instead. The second one is the use effect. So imagine that we had to like send in a post request after our component was rendered, or we had to change the title of the document after the component was rendered. So for this thing, we would use to do component mount or component update, and we would often end up pretty much doing the same thing in those both methods. Here we have the use effect hook. So in use effect, we pass a function, and this function will be called once React was done rendering our component for the first time or for any other time. So in this case, we sort of like combine useState with and use effect in such a way that after every render, we will change the title of our tab of our browser to a text that includes the current count. And here it's actually very elegant, just because we don't need an additional API to access state from the use effect function. They're already in the same scope. So if you want your effect to rely on the state, you just declare the state a little bit higher, and then you can use it in the use effect one. Some effects, such as subscribing to some information or like setting an interval, may require doing some cleanup work. And the use effect API allows for that very easily. You can return a function from use effect, and the function will be run when your component goes out of the world. So thanks to that, it's actually very easy to pair the subscription with unsubscribing code together, so they live together, and it's less error prone to like change one and forget about the other. And also, what's important to know is that React will rerun the effect actually every time the component re-renders. So if your information changed, like the friend property that I mentioned earlier, if this changed, the change would be reflected by the effect, because the effect is run every time. So to talk more about this idea, let's recap on the class style subscription that we had the component did mount and component will unmount for the code that we have already seen, and see how it would be done in hooks. So then we would just need to have the use effect, which would subscribe to the friend status, and it would return a function that unsubscribed to the friend status, and that's pretty much it. What we need to do. The hooks mechanics will take care of the rest. And this stuff reruns on every render. So like after every render, we would just unsubscribe from the old friend, subscribe to the new friend, and if this was the same friend, then that would be a unnecessary operation. So with use effect, there is some additional ways of being able to say when this effect needs to be rerun on and when it doesn't. And this is done very easily by another argument, which is an array of values that are the outside dependencies. So only if any of this value has changed, only then would React rerun the effect. So in this case, we would reset the document title only if the count changed. And similarly, in our subscription example, we would only resubscribe if the props friend ID changed. So just by adding this additional information here, we are able to have this code be really optimized. And funny enough, probably there will be auto tools or like some IDEs will have this capability of being able to figure out this information about what are the outside dependencies, especially like static type checking tools like Flow and TypeScript. We'll be able to figure it out and just say that whether you have correctly like listed them or not. So this will become pretty much automatic as well. And the third one, the kind of like the shortest one, but I include it for completeness, is the UseContext one. So as you know, there is this cool context thing in React that lets you pass information down the tree without actually passing this in props. And how the way you receive the context is by having this team context, having this consumer additional component, which has to have a function as children, and this function will receive the context as in here. But this again adds to the hierarchy complexity. So there is a hook for accessing the information in a simpler way. And this is done just by using the UseContext function, passing in the context identifier, and then you just get the context, and that's it. What used to take many lines of code can be just done in one line of code, and no additional consumer wrapper will be required. So when you pop on this developer tools in Chrome and go to the React tab, then you will just have a less components to look at and less work to do to figure out where the bugs are. So here there are certain rules that need to be applied when working with hooks. So first of them is we should name our hooks by prefixing them with use, such as like use state, use effect, and use context. And that's important for lint pretty much, and also for like just having a guideline of what is what and what can have what effects on our render method. So that's the way to name it. And also, we can only call hooks at the top level, and this has to do with the ordering. Like you can't be like, okay, I'm going to call this hook in a loop or in a if statement, just because it could change the ordering, and React only can distinguish the hooks just because of when they happen. So it's very important to keep that in sync. And the way to do it basically is to do your hooks at the first thing that you do in your render code. The other thing is the hooks are only meant for React functions, so there is no you can't call them from classes. That will not work, and it's just hooks are meant for functions. And also the hooks can be called from another function which is being called by React functions. So you can take a few hooks calls, wrap them in another function, and be using this function then. So that's a way of creating your own hook that we will look into a little bit more later. And there is a Async plugin that makes sure that that you follow those rules. And this is just a simple stuff. Anyway. And the reasoning for the hooks is just for those rules is the ordering, as I mentioned. So React will only see that you said use state, use effect, use state, use effect in a certain order. It will not make any meaning of how you use them or like what data you passed as initial state, because it doesn't matter. It only looks at the order. So the way to do it is just do one after another in the certain order. And also, please beware of conditionals. So if you only want to run your effect at certain condition, then check for this condition inside of the effect, right? Because the use effect needs to happen at the same point in your application. And that means that if in your render function you would often be like, okay, if this property is like not what I would like it to be, then just return null, and you do the early return kind of thing, then please check that there are no hooks being run after the early return, because this also breaks the rules. So additional hooks have to do with reducers that are sort of idea from Redux, that you can have some more sophisticated way to manage state. Use callback and use memo are the things that allows you to run functions in more optimized way. You have a hook for references, for adding methods to certain elements, and to add effects that have to do more with animations and the DOM structure. So the really idea behind hooks is to replace everything that the classes were capable of. And for the custom hooks, a simple example for about the subscribing to friends. So let's say we have different components that need to know if certain friend is available or not. So we can encapsulate all this logic in a separate function called the useFriend status. And this would require one piece of state saying whether or not the person is available, and also an effect of subscribing and unsubscribing to this data. So we have two hooks calls wrapped in another function, and then we are free to use this function in any component that we had to. So if we had the friend status component, which only returns text, that can use the hooks, being written as our custom hook function now. And also if we had the list item, which follows the same thing, this would be it's also very easy to do it. And the naming convention comes very handy right now, because if it starts with use, we know that it can potentially have state, or it can potentially have effects. right? So this is how you write an awesome React code using those new mechanisms. And the best story about all of this is this 100% backward compatible. And Facebook itself does not have plans to replace the current classes components. So no need to rush and rewrite everything into hooks. But there is really cool stuff that's really worth to consider for any new project and any new component, pretty much. Thanks.